Water. It's the symbol of vitality. It's the one element that all living things need to survive. The amount of water on Earth has remained fairly constant for billions of years. It's continuously being recycled by Mother Nature. Just think, the water in this apple could have fallen as rain halfway around the world last year, or been part of a lake that dinosaurs drank from more than 1 million years ago. And the water we use today will be used again and again by future generations. Unfortunately, Mother Nature cannot recycle quickly enough on her own to meet everyone's need for clean water. That's where we come in. The average person uses about 80 gallons of water every day. The byproduct of this becomes wastewater. Most of us don't think about what happens to all the wastewater once it goes down the drain. But in the Sacramento region, it empties out here, the Sacramento River. But not before being cleaned and treated. Our community relies on the Sacramento Regional Wastewater Treatment Plant to ensure the water being released is safe for the fish, the plants and animals that live here, and for everyone miles downstream. But treatment has only been a priority in developed countries since the late 1800s. Even today, some countries still don't have this technology. Recent photos of a village in India showed garbage piled in the streets and fresh water pipes running over open waste trenches. Runoff from this raw waste can enter into their rivers, streams, and freshwater supplies. Not much different than the ways ancient civilizations disposed of their waste thousands of years ago. One of the earliest discoveries of primitive wastewater systems dates back as far as 3200 BC. On the Orkney Islands, north of Scotland, rough winds and seas unearthed the ancient village of Scotta Brae. These stone huts had beds, shelves, dressers, and sideboards all made of stone. Evidence of a sophisticated drainage system was found in the village's design, one that may have included a primitive form of toilet in each dwelling. The earliest evidence of indoor bathing and plumbing was discovered in the ruins of the Mohenjo-Daro in the area that is now Pakistan. Rain and well water filled the Great Bath, which was used for religious functions. For personal bathing, almost every house had its own bathroom. The dirty water went out through brick pipes that emptied into a city drain system in the street. Covered openings let workers in to fix drainage problems. The raw wastewater then dumped into the Indus River. The elaborate drainage system was centuries ahead of its time. But unfortunately, the Mohenjo-Daro civilization died out, taking its drainage engineering with it. In Rome, tenements were several stories high, and very few of these households had pipes to dispose of the wastewater. So the waste was stored in chamber pots until they were full, then dumped out the nearest window into the street. Injuries from dumping chamber pots happened so often that Rome passed a law called the Dejecti Effusive Act, which awarded damages to anyone injured by the contents of the pot. However, no compensation was paid for damaged clothing, and oddly enough, the law only applied during the day. At night, street cleaners would wash the waste into channels. The Cloaca Maxima, originally built to drain the Colosseum, was one of the largest channels that carried waste and water to the Tiber River. This early sewer remained in use for over 2,000 years, and parts of it can still be seen today. In 1665, lack of proper waste disposal took a deadly turn in London. Because of the excessive waste, the rat population grew at an alarming rate. People started becoming sick and dying, and no one knew why. The sickness was bubonic plague and caused over 60,000 deaths in 6 months. Symptoms were spots surrounded by red rings, sneezing fits, and finally collapse, as described in the familiar nursery rhyme, Ring Around the Rosie. As populations continued to grow, so did pollution to the city's freshwater supply. This caused other types of diseases, like cholera. By the mid-1800s, cholera epidemics were seen throughout the world. New York City had thousands of deaths from an outbreak. Even Sacramento reported over 1,000 deaths from the disease. London was reeling from cholera, but Dr. John Snow would make a significant observation regarding the spread of the disease. He plotted the location of the deaths on a map and realized that most sick people drew their water from a pump on Broad Street. Snow surmised that a sewage facility emptying into the fresh water supply upstream contaminated the pump. He finally convinced city leaders to let him remove the pump handle as an experiment. The spread of cholera dramatically stopped. The experiment was a success. Developed countries quickly began to realize that proper sewage disposal was critical to the health of their communities. Leaders nationwide became proactive. Sacramento began operating its own sewage disposal system in 1878, and by the late 19th century, our system consisted of a series of main sewers running through what is now downtown. As the population grew, so did our system. New technology was added as it became available. By the early 1900s, a nationwide shift in thinking started to take place. Engineers worked on basic methods to clean the raw wastewater before returning it to the waterways. During this transition stage, efforts continued to improve, but only the largest U.S. cities had treatment plants. Most of the smaller cities continued to dump untreated wastewater into local rivers and streams. Then in 1952, an oil slick caught fire on the Cuyahoga River in Cleveland, Ohio, causing extensive damage. There were several smaller fires that followed, including the one in 1969 that received national attention. This created the rallying point for environmentalists in their fight for cleaner water, and sparked the United States Clean Water Act of 1972, which required the states and the EPA to set standards for surface water quality, mandate sewage treatment, and regulate wastewater discharges into the nation's surface waters. In answer to this call to action, the Sacramento Regional County Sanitation District, SRCSD, was formed in 1973. The job of sewage collection and treatment in the region, which was being handled by separate city, county, state, federal, and private agencies, was consolidated. The Clean Water Act provided billions of dollars in federal funds to help construct treatment plants throughout the country. SRCSD was awarded the largest single grant in the nation. The grant, along with state and local bonds, helped construct a $460 million plant, and the Sacramento Regional Wastewater Treatment Plant went online in 1982. Today, the plant serves more than 1 million residents and discharges an average of 165 million gallons of treated wastewater a day into the Sacramento River. But they can't do this alone. SRCSD works closely with local sewer agencies to collect and transport wastewater to the treatment plant in the southwest corner of the county. Smaller pipes leaving your house connect to larger pipes under the street. As more and more lines merge together, the pipes get larger. Some are as large as 144 inches in diameter. Avoiding breaks and spills is high on the priority list. Over the past 30 years, regulations regarding the care and maintenance of the system have become much more stringent, and so have the treatment requirements. But the basic principles of the process have remained the same. Large materials like trash and tree limbs are removed from the incoming wastewater by bar screens. The screened water enters underground primary settling tanks where most of the remaining solid materials, like sand or gravel, fall to the bottom and are removed. Next, the wastewater enters the oxygen reactor. Naturally occurring microorganisms consume the dissolved organics and sink to the bottom. In a second series of settling tanks, the cleaner wastewater flows out over the top. Chlorine is added to kill any harmful organisms remaining in the wastewater. The water travels 2 miles to the outfall, the release point on the bottom of the Sacramento River. Finally, sulfur dioxide is added to neutralize the chlorine. But the water isn't just released and forgotten. Enter the Guardian. Under the direction of Captain Mike Cook, the Guardian goes out weekly to collect water samples both above and below the release point. He also checks water temperature.
And then we do a visual inspection of the way the river looks. Is there a lot of floating debris? Is there a lot of fungus? Is there a lot of oil on the river?
The water samples go back to the lab for testing to verify the treated water is safe for the fish, plants, and animals that live along the river. But not all of the treated water goes back into the river. In the late 1990s, the plant began installing a water recycling system. The system uses this purple pipe to help identify the recycled water. By 2003, the plant and several local Elk Grove communities began using this recycled water to irrigate parks, schools, commercial sites, and roadway medians. Today, up to 3 million gallons of water per day is pumped to a recycling tank where it's filtered and disinfected for landscaping uses. An expansion is now underway to extend the use of recycled water to other areas. But this environmental consciousness isn't limited to water recycling. There have been huge advancements in other areas, like energy. The sludge and microorganisms left over from the bottom of the settling tanks are put into digesters to break down the solids. One byproduct of this process is methane gas. The Carson cogeneration plant, right next door to the treatment plant, buys the gas. They use it to produce electricity, enough for about 50,000 homes in Elk Grove, and they sell enough back to the treatment plant to run the digesters. Carson also uses the gas to produce steam, which serves as an energy source for a private on-site ice producer. Recycling the methane has led to cleaner air and an alternative energy source, which benefits the entire Sacramento region. Well, you'd think after all of this treatment and recycling there wouldn't be anything left. Not so. There are still leftover solids from the digester. In the past, these biosolids went to lagoons for treatment. Later, a dredge would pull it up from the bottom of the lagoons, and tractors would then inject it into on-site line disposal areas. But thanks to advances in technology, scientists and engineers have figured out how to turn almost 30% of our biosolids into a reusable product, fertilizer. SRCSD and Synagro Technologies have joined forces to operate this state-of-the-art biosolid recycling facility that went online in January of 2005. This plant is California's first facility to use heat drying to create fertilizer pellets from biosolids, and one of only 13 similar recycling facilities operating nationwide. The plant currently processes over 7,000 dry tons of biosolids annually into high-quality organic fertilizer that is marketed in California. Jointly, the treatment plant, cogeneration plant, and the biosolids recycling facility work together to reuse as much waste product as possible for the health of the environment and the community. These are just some of the ways the Sanitation District is currently working with other agencies and organizations. They're also branching out to work with area developers and park, planning, utility, transportation, and environmental agencies to establish the Upper Laguna Creek Corridor. This collaborative planning process is taking a proactive approach to the area's growth. The corridor is being designed to accommodate stormwater runoff, healthy stream and floodplain waters, underground pipelines, wildlife, and recreation trails. This three-phase plan is slated to guide the development of the Laguna Creek watershed area through the year 2023. But this close attention to neighbors and wildlife isn't new. In the 1970s, habitat specialists suggested that the 2,600 acres surrounding the treatment plant could benefit the community and environment by becoming a wetland preserve.
We could just put a fence around the entire property and call it good. But what we try to do out here is recreate the habitat that existed hundreds of years ago, and then we manage that habitat.
Conserving what we can, recycling, and preserving the environment are our goals. They go hand in hand. John Muir once said, "When we try to pick out anything by itself, we find it hitched to everything else in the universe." Nowhere else is this more evident than in the preservation of our freshwater sources.